Dear learners, welcome back to NPTEL online certification course on novel drug delivery system. I am Dr. Satish Devanapelli, Assistant Professor at Department of Pharmaceutical Sciences and Technology, Institute of Chemical Technology, Mumbai. So, in our previous classes, we have started with the new topic, that is the gastroretentive drug delivery systems. In that, in our previous class, we have discussed, so what are the gastroretentive drug delivery systems, and then we have learned what are the need for the gastroretentive drug delivery systems, and in that we have seen the various advantages and the applications of the gastroretentive drug delivery systems, and further we have discussed various mechanisms which are involved in the gastroretentive drug delivery systems. Not only that, we have discussed other topics which are related to the gastroretentive drug delivery systems. So, in our previous class, we have ended our presentation with the types of gastroretentive drug delivery systems. So, today I am going to discuss on various types of the gastroretentive drug delivery systems, which are commonly known as GRDDS. So, this is the today my flow of presentation. So, here you can see in the first, it comes with the low density or floating gastroretentive drug delivery systems, and this further divided into the non-effervescent gastroretentive drug delivery systems and the effervescent based gastroretentive drug delivery systems. And then we will discuss on the other topic, which is high density gastroretentive drug delivery systems, and then we will see expandable and then superporous hydrogel drug delivery systems, and then we will see further topics, that is the mucoadhesive gastroretentive, Raft-forming, and then we will focus on magnetic gastroretentive drug delivery systems, and then we will see ion exchange resin based drug delivery systems. So, as we discussed in our previous classes about the need of the gastroretentive drug delivery systems, and in our previous class also we have discussed the limitation of the oral drugs is nothing but the gastric emptying is one of the major problem, and there are the drugs which are which required the at particular site the drugs will undergo absorption, which are nothing but narrow absorption or therapeutic window, and such drugs, and there are the diseases, and such diseases your drug need to be available in the gastric time. So, the ultimate principle is that to retain or to prolong the release in the GIT conditions, the GRDDS systems are the best formulations. We can convert conventional oral formulations or oral active molecules into the gastroretentive drug delivery systems. With that, we will increase the retention time in the GIT, and also that will help in the prolonging or to release the drug at the localized site, which will ultimately enhances the bioavailability of the drugs. So, in that we are going to discuss on various types of the gastroretentive drug delivery systems, which will ultimately help in the increment in the retention time of the drugs. So, in that the first topic is nothing but floating systems, and by seeing this title you will understand that there is a mechanism which is required to float your formulation in the GIT fluid. So, this is also known as low density gastroretentive drug delivery systems. Now, these systems are designed by using of some of the agents, or you can say some of the polymers and the combination of the excipients, which will help in the floating of the formulations. And now we know that the gastric content which is available in the GIT condition and the stomach, and it has a density of 1, and these systems must to be float on in the gastric fluid. For that, we need to use various mechanisms that will help to float your formulation in the GIT fluid. So, here the mechanism is nothing but buoyant. So, here in the buoyant, the definition you can see here, which already mentioned, the buoyancy is the tendency of an object to float or rise when immersed in a fluid, nothing but after taking of any tablets or any type of the oral dosage forms, then your formulation will absorb the water and it will undergo into the sink condition. That means, your formulation will settle in the GIT fluid. So, yes, that is very important for the as in a mechanism for the after the route of administration. But here this is a one mechanism, with this we can avoid the gastric emptying, or you can say that we can increase the retention time in the GIT. So, by using of this the buoyancy mechanism, we can float the our formulation, and that your final formulation need to have the bulk density lower than your GIT fluid. Then only your formulation will float on the GIT fluid, and this property will allow for the floating in the stomach, that will help for the prolongation of the drug release, and yes, with that we can achieve the desired effect in the body. So, you can see by seeing the pictorial representation, after administration what happen, your medicine will or your tablet will come into the GIT fluid, and it will take the water, and then it will move away from the stomach. But by using a floating system, it will completely avoid the gastric emptying, and it will float on the surface, or you can say on the GIT fluid, because of which contains the low density, which is lower than the gastric content. So, the first topic we are discussing is the floating systems, or you can say low density gastroretentive drug delivery systems. So, in that first topic is non-effervescent floating systems, or you can say non-effervescent low density GRDDS. In that we will use various polymers which will swells in the GIT fluid. That is, best example is hydroxypropyl cellulose, that is HPC, and the hydroxypropyl methyl cellulose. These are the two best polymers which will swells in the GIT fluid, and they form the gel barrier upon the hydration, that will help in the floating. So, yes, here also we get various types of the polymers. Again, in the HPC and HPMC, we will get different grades based on the viscosity, and as per the need we need to do some optimization studies, then we can select the right polymers for our studies. So, the mechanism is it forms the gel barrier that will help in the for the floating. So, here these are the formulations we can make as in a non-effervescent floating systems. We can make floating tablets and also micro balloons. We can also prepare microspheres or microparticles. We can also prepare non-effervescent beads as well as pellets, which will help as in a low density gastroretentive drug delivery systems. So, here we can see the example is hydrodynamically balanced systems. Now, you can see these are the capsules which are prepared with the same polymers, and after administration, so you can see what happened, the gastric fluid is coming and interacting with that. You will see there is a change in this their surface. It is this GIT fluid is interacting and it undergo the swelling, and this will help in the retention. And further, with the help of some cases we use even the CO2 release mechanism, that is effervescent mechanism, that will help also in the floating of the your system in the GIT fluid. Now, here you can see what happened once it is swell and then it will float on the surface of the GIT fluid. So, the one best mechanism is nothing but hydrodynamically balanced system by using the swellable polymers. Again, here you can see the another topic, that is colloidal gel barrier systems. Now, here we use various types of the hydrocolloids, which specifically we can use up to 22 to 75% of the hydrocolloids after administration. So, it will interact with the gastric fluid, and you can see in the outer layer your polymer will swell, that forming the colloidal gel barrier, which after taking of the GIT fluid and then forming of colloidal gel barrier, you can see the density is less than the gastric fluid. So, with this it will also help to convert into the non-effervescent floating systems. So, with this we can also make various types of the low density floating systems. Now, in another topic, it is effervescent floating systems. We are discussing low density floating gastroretentive drug delivery system. First we have seen non-effervescent floating system. Now, we are seeing the another topic, that is the effervescent floating systems. We know that the effervescence which comes with the weak acids and the weak basics in presence of the water. The best molecules are sodium bicarbonate, citric acid and the tartaric acid. Other types of the acids we can use. When you mix these two ingredients, weak acids and weak bases, and when you put it in the water, that will liberate the CO2, right. So, same principle people have used to generate the gas, and that will lift your medicine, or that will lift your dosage form on the top of the stomach fluid. So, this will happen in the stomach fluid. Once here CO2 gets trapped in the gel matrix, that causes the flotation. So, here you can see in the pictorial representation. So, here we can use the drug molecules that we need to prepare the sustained release drug molecules in the core, right. Upon that we can use the sodium carbonate and the tartaric acid layers. This is the effervescent layer, and the top of that we use the polymer that we are going to take the water molecule and it will swells. So, here it is in the effervescent we can also use combination of polymers as well as the CO2 generating molecules. So, here also you can see the best example, drug effervescent material and the release control polymer. So, three components we will make into one dose, and then it will take the water and it will generate the CO2, and that will help in the floating of the formulations. Yes, you can make as a single layer as well as bilayer tablets. We can make floating capsules and multiple unit capsules, and formulations are the variable because of the gastric ratio and the polymer ratio, and that will affect the your floating time and the release rate. So, here we need to consider two major ingredients, that is the polymers and the effervescent generating agents, this ratio is very important for the floating of the systems. So, these are the effervescent type of the floating systems in the low density gastroretentive drug delivery systems. So, now in the second topic we are going to discuss on the high density gastroretentive drug delivery system. This is completely opposite to the low density gastroretentive drug delivery system. What happens in conventional formulations, your tablet will, after administration, as we know that because of the pathophysiology and the gastric emptying mechanism, your formulation will come in contact with the GIT fluid and then certain amount of drug will release, consider 10 to 20% of drug will release and then remaining will taken away by the physiological system, that is a gastric emptying. So, this is the one of the major limitation. So, people have discovered, people have invented various types of the gastroretentive drug delivery systems which will help in the retention of the dosage form within the stomach. So, in that the second thing we are going to discuss high density gastroretentive drug delivery systems. As we know, it is completely opposite to the low density gastroretentive drug delivery systems. Now, here you can see the density of the final dosage form is very high compared with the density of the gastric fluid in the low density gastric retentive drug delivery systems. Now, here this formulation will not float, this will sink in the bottom of the stomach. That is the principle which is involved in the high density gastroretentive drug delivery systems. Now, you can see here the formulation after administration, it is remain and retained in the particular site. So, you can see it will remain in the rugae folds of the antrum that will control the peristaltic movement and that will help in the gastroretentive drug release for 6 to 24 hours, whereas conventional it may happen up to 3 to 4 hours, but when use high density gastroretentive drug delivery systems, with this you can expect the longer time of the release. Yes, for that we need to use various types of the materials which contains the high density as an excipient. The remaining API we need to provide and other tablet or capsules which are required to make the formulation, that also need to incorporated in your formulation. But yes, along with this we need to use some of the important materials which are high in the density. The first example is barium sulphate and second is the titanium dioxide and third one is the zinc oxide. These three materials we need to utilize in the preparation of the high density gastroretentive drug delivery systems. Now, these formulations are required where such drugs are not suitable to make the low density gastroretentive drug delivery systems. That means, if a drug has a high density, you cannot use the low density drug delivery systems, and also if your formulation is not compatible with the effervescent, and such cases also we can use the high density gastroretentive drug delivery systems. And the great advantage is that because as we learned in last class, gastric emptying is the one of the major challenge, right. So, when you have fasted state and when you want to resist the gastric emptying, such cases we can go with the high density gastroretentive drug delivery system, which are very effective compared with the other types of the gastroretentive drug delivery systems. We can use same formulation for fasted state and also we can avoid the gastric emptying compared with the other types of the gastroretentive drug delivery systems. The major limitation is that if a drug has a high dose, you cannot make the such type of the high density formulations, because your material they also have high density. Such cases we need to look for the alternative formulation. The third topic we are going to discuss on the expandable gastroretentive drug delivery systems. So, as we understand by seeing the pictorial representation, now you can see in the slide. So, this is the tablet and this is the capsule. So, it has the expandable gastroretentive drug delivery systems are classified into two types based on the mechanism. So, here the first is the swelling or swellable expandable gastroretentive drug delivery system. The another one is unfolded expandable gastroretentive drug delivery systems. Now, we will see there is a change in their volume as well as you will see the change in the shape after administration. So, you will see the change in their physical form, right. So, after administration it will take the water and it will increase their surface or they increase the shape. Now, here in case of unfolding, here what we do, we will put a folded medicine or in the films which are folded, we will load into the capsules and after administration this will expand into the required size. So, with this also we can avoid the passage of the molecule from the pyrolic sphincter which will available in the end of the stomach part. So, with these expandable systems we can avoid the gastric emptying from the stomach. So, it happens in three different stages. So, at stage 1 the size is very small and is easy for intake. After administration it will expand in the stomach to prevent the gastric emptying. After the complete release the size will decrease and that will easy for the removing from the stomach. So, size reduction also is very important after the administration, after the release. So, ultimately it will help in the longer gastric residence by using the expandable gastric residence systems. Now, here in the expandable we have two different types of systems, that is swellable and the previous one unfolded one, right. So, in the swellable here we use various types of the polymers which will swells. As we know, like hydroxypropyl methyl cellulose, polyethylene oxide and the carbopol are the best examples that will absorb the water and then swells from the gastric fluid and then increase the volume of the systems and the size will enlarge and that will avoid the escape from the pyrolic sphincter and after that this will may shrink after the complete release. Now, in the pictorial representation you can see, so this is collected from this paper, preparation and characterization of novel swellable floating gastroretentive drug delivery systems for enhanced oral bioavailability of nilotinib. So, this drug is used for the anti-cancer applications and yes, this has the oral application also, right. So, to improve the bioavailability, so scientists have used various types of the polymers HPMC, hydroxyethyl cellulose and the collidone. Now, you can see they tried with the various ratios and they have checked the solubility of the polymer in the various fluids. Now, you can see the ratio here, the polymer ratio is less, very less. Now, you do not see any type of swelling in the tablets. But when you increase the polymer ratio, now you will see there is a swellability which is very high in some portion, right. So, with that we can improve the gastric residence time by using of the swellable polymers. So, the best example is HPMC and polyethylene oxide, also here it is mentioned, that is polyvinyl acetate and hydroxyethyl cellulose, which can also help in the swelling of the gastroretentive drug delivery systems. And the another one is unfolding gastroretentive drug delivery system. As I mentioned, what we do, we fold the final formulation in the capsule. After administration, the capsule will disintegrate in the body, in the stomach, then it will take water, it will take the fluid from the GAT and then it will expand the size. So, with this will help in avoiding the gastric emptying. So, we can read here, we use polymer and the drugs which are folded or compressed state in the gelatin capsule. The folded doses expands into the larger configuration made using shape memory biodegradable polymers. Now, here these are the various types of the unfolding gastroretentive drug delivery systems. With this we can make 4 lobe type of the GRDDS, disc and limbed cross, ring type, tetrahedron type. So, with this we can make various types of the unfolded gastroretentive drug delivery systems. So, with this we can convert various types of the conventional oral formulations into the gastroretentive drug delivery systems. With that we can enhance the bioavailability of our formulation by modifying their properties into the gastroretentive drug delivery systems. So, with this we are going to stop today's lecture. So far we have discussed on 3 types of the formulations, that is, first we discussed low density gastroretentive drug delivery systems, and then we have discussed high density gastroretentive drug delivery system, then we have discussed expandable gastroretentive drug delivery systems, and with this we are going to stop today's lecture. In our upcoming class we are going to discuss on the various types of the other gastroretentive drug delivery systems. Thank you so much.